Hello, my phenomenal viewers, and welcome on today's episode. On today's episode, we will be answering this GCE 2020 question 1. The question is on the probability, and the question reads: two events A and B are such that probability of A is equals to 1 over 3, probability of B is equals to 2 over 9, and probability of A giving B is equals to a half. Find A. Probability of A intersection B, probability of A union B, C, probability of B given not A. So like I said, the question is under probability. And before we begin answering this question, I would like to give a brief introduction on what probability is. So when we talk of probability, probability simply refers to the measure of the likelihood of the occurrence of an event. That is how likely an event is to occur. What is the chance or what is the possibility of a certain event occurring refers to the probability of that event. And probability usually has a range. It ranges from 0 up to 1. So if we have a certain event, then its probability must lie within this range. 0 is lesser than or equal to the probability of that event occurring. For instance, if the event is A and the probability of that event occurring is lesser than or equal to 1. So this is the range that all probabilities must satisfy. If you calculate any probability and you end up with a value that does not lie within this range, that is a value that is lesser than 0, a negative value, for instance, or a value that is greater than 1, then you have to go back and check your solution because you've made an error somewhere in your solution. So this is the range that all probabilities must satisfy. Now, an event that has a probability of 0, it shows that that event doesn't exist. The event can never occur. Then an event that has a probability of 1, it shows that the event is certain. The event must occur. Now, coming back to the question has given us two events A and B and their probabilities respectively. And the question has asked us to determine the probability of A intersection B. This probability A intersection B simply refers to the probability that both events A and B are going to occur at the same time. And looking at this probability, we need to look at this other probability that has been given to us, which is probability of A occurring given that B has already occurred. So this is a conditional probability, which is what is the probability of A occurring given that B has already occurred. In this case, the probability given to us is a half. So this probability, there is a formula that is used to calculate this probability, and that formula is probability of A occurring given that B has already occurred is equals to probability of A and B occurring at the same time divided by probability of B occurring. So from this formula, you see that we can obtain the probability of A intersection B, or the probability of A and B occurring at the same time, since we know the probability of A given B and the probability of B. So this implies that probability of A intersection B is equal to probability of A given B times probability of B, and this is equal to probability of A given B is a half times probability of B, which is 2 all over 9. And when you simplify this, you are going to end up having 1 all over 9. So this is the probability of both events A and B occurring at the same time. If the A part of the question has been understood, then let us move to the B part of the question that has asked us to calculate the probability of A union B, the probability of A or B. Now this probability has its own formula as well. So the formula of probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So this is a formula that you need to know. Same with this other first formula that we saw earlier. So you need to know all of these formulae under probability. So we know the probability of A, the question has given us to be what? 1 all over 3. Probability of B is 2 all over 9 minus probability of A intersection B, which is the probability that we obtained from the A part of the question, which is 1 all over 9. So this gives us 1 all over 3 is the same as 3 all over 9. When I multiply top and bottom by 3, or the numerator and the denominator by 3, I'm going to have 3 all over 9. So I'm doing so to ensure that all of the denominators are the same. Now, since all of the denominators are the same, I will just add and subtract the numerators. So this gives me the probability of A union B to be 3 plus 2, 5 minus 1, 4, 4 all over 9. So this is the probability of A union B. So this is how you obtain the probability of A union B. You see that we've used the probability of A intersection B in order for us to determine the probability of A union B. So had it been that you made an error in determining the probability of A intersection B, then obviously you are going to fail the probability of A union B as well. So if this B part of the question has been understood as well, let us move to the C part of the question that has asked us to determine the probability of B given that A has not occurred. So this probability is read as, what is the probability of B occurring given that event A has not occurred? So this probability is equivalent to probability of B given not A is equal to probability of B intersection not A divided by probability of not A. So this is the equivalence of this probability. Probability of B intersection not A divided by probability of not A. Now, probability of A not occurring has a relationship with the probability of A occurring. And that relationship is that probability of not A is equals to 1 minus probability of A. So the probability of an event occurring and an event not occurring have this relationship, which is when we sum the two probabilities, we must have 1. That is, when we take the probability of an event occurring and we add it to the probability of that event not occurring, we must have 1, because these two events are exhaustive events. So this is the relationship that exists between the probability of an event occurring and the probability of an event not occurring. So from here, we can see that the probability of A not occurring would be 1 minus probability of A occurring, which is given to us in the question as 1/3. So 1 minus 1/3 gives us 2/3. This gives us 2/3. Now, this probability was not given to us in the question as well. But now we can further break this down. And when we further break this down, it becomes probability of B minus probability of B intersection A, or probability of A intersection B. It doesn't matter the manner in which we arrange the two events. Now, I usually use a Venn diagram to explain this probability. So for instance, given that you have a Venn diagram like this, and you have two sets, set A here and set B. So the portion of this Venn diagram that represents this notation, that is B intersection A prime, is this portion of the Venn diagram. Now, this portion of the Venn diagram can be obtained using the total elements that are found in set B. Remember, this is set B, and any element that is found within this region is found in set B. So if I take all of the elements that are found in set B and I subtract the elements that are found in both set A and set B, which are these elements here, I'm going to have elements that are found only in set B. So this is the same as probability of B, which is all of this probability minus probability of A intersection B, or B intersection A, which is this probability. So when I take the entire set B and I subtract this part, I'm going to be left with this part, which gives me this probability. So all of this is being divided by probability of A not occurring, or not A. So this gives me the probability of B occurring 2 all over 9 minus probability of B intersection A or A intersection B, 1 all over 9 divided by this probability, which is 2 all over 3. So this is 1 all over 9 times 3 all over 2. When I change the division sign to a multiplication sign, it gives me 3 all over 2. So this is 1 all over 6. So this gives me 1 all over 6. So probability of B occurring, given that A has not occurred, is equals to 1 all over 6. Now, there is a D part, E part, and an F part of this question. I think the D part of the question has asked us to determine whether these two events are independent events. Then the E part of the question has asked us to determine whether they are mutually exclusive. And the F part has asked us to determine whether the two events are exhaustive events. Now, when we say two events are independent events, it simply means that the probability of A intersection B, or the probability of both events occurring, is equal to the product of their probabilities. So this is the probability of both A and B occurring, which is 1 all over 9. If this 1 all over 9 is equals to the product of these two probabilities, then we conclude that they are independent events. So probability of A intersection B is equal to probability of A times probability of B. When this condition holds true, then we see that the two events are independent events. So let us see whether when we multiply these two probabilities, are we going to end up having 1 all over 9? If we have 1 all over 9, then we are going to conclude that the two events are independent events. Probability of A is 1 all over 3 times probability of B, which is 2 all over 9. When we multiply these two probabilities, we are going to have 2 all over 27, which is not equal to 1 all over 9. So hence the two events are not independent. Now for the two events to be mutually exclusive, this simply means that the two events cannot occur at the same time, meaning that the probability of A intersection B is equal to 0. And since the probability here is different from 0, then the two events are not mutually exclusive as well. So for mutually exclusive, probability of A intersection B is equal to 0. So since the two events are not having a probability of 0 for them to occur at the same time, then the two events are not mutually exclusive.